Hello everyone, myself Punnam. I am working as assistant professor in EEE department at Mlritm. Today I am going to explain the concept of time response analysis from a control system topic. So the outline of presentation is introduction to a time response analysis, concept of a time response analysis, standard test signals and time response of a first order system. So time response analysis is control system involves in examining how the system's output changes over a time when subjected to an input. Its fundamental method for evaluating the performance and stability of a control system. This analysis helps determine how quickly a system reacts to change, how accurately it reaches a desired state, and how well it settles that state. So, time response analysis, as defined earlier, time response is a response of a control system as a function of a time. So, see here, this is a time axis and this is output C of t. The time response analysis is divided into two parts. First one is transient response and a steady state response. We will see it later what is transient response, what is steady state response. But for time being, this up to this part, this is a transient response. After that, this is a steady state response. The total response of a system is combination of transient response and a steady state response. So C of t is equal to C of t transient response plus C of t steady state response. Now, the standard test signals. Test input signals are used for testing how well a system responds to a known input. The standard test signals are impulse, step, ramp, and parabolic. The signals are used to know the performance of a control system using time response of output. The standard test signals, as I told you, impulse, step, ramp, parabolic, and sinusoidal. So these are the standard test signals. We will study about one by one of a standard test signals. First one is impulse input. Impulse signal exists at t is equal to 0 only at t is equal to 0. This is an ideal impulse signal. But in practical case, this is a practical case. So height is a and this width is 1 by a. So area under curve is equal to 1 by a b into h. A is unity. So see here, at t is equal to 0, the signal is existing. Elsewhere, it is a 0. So the Laplace transform of r of t is 1. So Laplace transform of impulse signal is 1. Next, step input. The step input exists from 0 to infinity. So u of t is equal to A. This is the height of a signal. This is the height of a signal A, or magnitude. It is also called as magnitude. So this is a DC signal or a step signal. So U of t is equal to A. So Laplace transform of U of t is equal to A by S. If it is a unity, A is equal to 1, then it is 1 by S. So Laplace transform of R of S, Laplace transform of R of t is equal to 1 by S. Or A by S. So step signal is exist from t is equal to greater than or equal to 0, otherwise 0. Next, ramp input. So this is a ramp input R of t. So at t is equal to 0, it is 0. As t increases, the signal is increasing with respect to time. See here, at t is equal to, t is greater than equal to 0, it is AT. Magnitude of a signal is A into t. Less than 0, t less than 0, it is 0. And Laplace transform of R of t is equal to 1 by S square or A by S square. If A is equal to 1, then 1 by S square. Next, parabolic signal. The rate of change of velocity is acceleration. The acceleration is a parabolic function. So see, it is a exponentially increasing function. With respect to time, it is exponentially increasing order. And the Laplace transform of a signal is A by S cube. Next, a sinusoidal signal R of t is equal to A into sine omega t. So with respect to time, it will changes with respect to time. So this is a sinusoidal signal. Suppose omega t is equal to 0, then it is 0. As omega t increases, the value of magnitude is increases, again becomes 0, then it will goes to negative, again it will increases maximum, then 0, negative. So the sine function is existing between -1 to +1. So this is about a standard test signals. Next, time response of a first order system. So order is defined as a highest degree of a polynomial is called as order. For example, ax square plus bx plus c is equal to 0. It is a second order system because the highest degree is 2. Next example, s square plus 2s plus 10 equal to 0. The highest degree is 2, so it is a second order system. And third example is s cube plus 10 s square plus 2s plus 1 plus 10s plus 2 equal to 0. So highest degree is 3. So order of a system is equal to 3. So highest degree of a polynomial is order. And the transient response depends upon the order of a system, and steady state response depends upon the type of a system. So in this case, the time response of a first order system is, consider the following block diagram of a closed loop system. Here an open loop transfer function is 1 by st is connected with a unity negative feedback. It is a negative unity negative feedback. So C of s by R of s output is C of s by R of s of a first order negative feedback system is G of s by 1 plus g of s into h of s. So here h of s is equal to 1 because it is a negative feedback system, unity negative feedback system. So g of s by 1 plus g of s. So in above case, in the first order system, g of s is given it as 1 by s into t. So 1 by s into t by 1 plus 1 by s into t. 1 by s into t by st plus 1. So this and this gets cancelled. 1 by 1 plus tau s. So c of s by r of s is equal to 1 by 1 plus tau s. So where tau is the time constant and s power is 1, so it is a first order. It is a first order system. Now see here, c of s by r of s equal to g of s by 1 plus g of s. So after substituting the g of s value, we will get 1 by 1 plus st or s tau. Now I want to find the response of a system. So response means output of a system. So here it is a output and this is a input. So c of s by r of s is transfer function is equal to 1 by 1 plus tau s. So now I want to shift this right side. C of s is equal to 1 by 1 plus tau s into r of s. So this is the output of a first order system, where c of s is output, r of s is input, and t is the time constant. Now, steps to get the response of a first order system in the time domain. First of all, we have to take a Laplace transform of a signal r of t. R of t is given input signal. Consider the equation c of s is equal to 1 by 1 plus tau s into r of s. We already know it, c of s by r of s, that is transfer function is equal to some g by 1 plus g of s into h of s. If g of s or g by g value is given 1 by tau, that is forward path gain is 1 by tau, then and your feedback is unity, then we will get like this 1 by 1 plus st. If it is given a forward path gain is something other function, then we have to substitute over here. We have to substitute here g of s plus. After that, we will get a transfer function, and then you shift the input signal to the right side. So finally, you will get a equation like this. It is a output equation. So now you substitute the value of r of s. You substitute the value of r of s. R of s is a input signal. So after that, you have to do some mathematical operation like partial fraction, and then you apply the inverse Laplace transform. Why we are applying inverse Laplace transform means to convert from frequency domain or s domain to a time domain. We have to perform a inverse Laplace transform operation, right? So the steps to get the response of a first order system in a time domain analysis, we have to take Laplace transform of a input signal, that is r of s, r of t. R of t is converted into a r of s. This is first step. So by doing Laplace transform, and second is we have to make a given block diagram into a standard equation, that is output equation c of s is equal to r of s into given function, given transfer function. Okay. After that, substitute the rs value. After that, we have to substitute the value of rs. Then we will get a c of s function, and r of s is multiplied with the forward path gain. So we have to perform it a partial fraction, something a by s plus b by 1 plus tau s, if it is r of s is equal to 1 by s. Okay. After that, we have to apply a inverse Laplace transform so that we will change the response into time domain from C of S to C of t. Okay, C of t is the time domain response of a first order system. Now, see here, impulse response of a first order system. So, now we have to determine the response of a various signals. First one is impulse signals, step signal, ramp signal, parabolic and sinusoidal. Okay, so first of all, I want to explain the impulse response of a first order system. So consider a unity impulse signal, that is R of t is equal to del of t. Okay, and what we have to do, we have to apply a Laplace transform. So then we get that R of s is equal to 1. This is the Laplace transform of a given impulse signal. Now consider a equation C of s is equal to 1 by 1 plus tau s into R of s. So this is the first order transfer function for a given block diagram for our example. Now R of s is equal to 1. So I am substituting over here C of s is equal to 1 by 1 plus tau s into R of s. R of s is equal to 1 is equal to 1 by 1 plus tau s. So C of s is equal to 1 by 1 plus tau s. Now take t as a common. If I take t as a common, then s plus 1 by tau. Now after rearranging 1 by tau by s plus 1 by tau. Okay, so this is seems to be a C of s is equal to 1 by tau by s plus 1 by tau. Now I want to apply a inverse Laplace transform for this. So inverse Laplace transform of C of s is equal to 1 by tau into e power minus t by tau, where tau is equal to 1 by t. Okay, see here. So C of t, after applying the inverse Laplace transform, C of t is equal to 1 by tau e power minus t by tau into u of t. Now C of t is determined. So C of t is the output of a or time response analysis of a impulse signal. Now I want to sketch a graph. Now substitute t is equal to 0 in this C of t. So C of 0 is equal to 1 by t into e power minus 0 by tau into u of t. So something by 0 is 0. So 1 by tau is equal to e power 0 into u of t. E power 0 is 1. So finally 1 by t is the value of C of 0. So initially means at t is equal to 0, the impulse response of a signal is maximum. As t progresses from 0 to infinite, if I substitute t is equal to infinite in this C of infinity or C of t, I will get a C of infinity is equal to 0. It means as time progresses, the response of a system is decreasing order. At t is equal to infinity, it will become a 0. So this is the impulse response of a first order system. Next, step response of a first order system. See, now I am considering same procedure. R of t is equal to u of t. Applying Laplace transform, I will get R of t, Laplace transform R of t is equal to 1 by s, and I am taking it as a unit step response. So a is equal to here, a is equal to 1. So this is the Laplace transform of a first unit step input. Now this is the output equation. C of s is equal to 1 by 1 plus st into R of s. Now I am substituting R of s over here. So I will get A by S into 1 plus ST. So as I told you earlier, I am performing a partial fraction. I am separating this term by A by S plus B by 1 plus tau S. So after rearranging it, I will get A value and B value, and A value is 1 and B value is T. Otherwise, I can find the A value directly by using this concept 1 by S into ST plus 1 into the denominator of A is S, so multiply with S and substitute S is equal to 0. So this S cancel, and 1 by 1 plus S into T, S is equal to 0, I am substituting into T. So 1 by 1 plus 0, that is 1. So I can easily find the A value, and after that similarly I also can find B is equal to 1 by S into S plus 1 plus S tau into 1 plus S tau, and substitute S is equal to minus 1 by T. So this cancel. So you will get T is equal to B is equal to minus tau. Okay. So now substitute this A and B values over here. So C of S is equal to A value is 1. So A by S or 1 by S minus B value is minus T. So minus T by ST plus 1. So this is 1 by S minus, I am separating, I am taking T as a common. So T by T into S plus 1 by T. T cancel, 1 by S minus 1 by S plus 1 by T. Then I have to apply a inverse Laplace for it. So inverse Laplace transform of a 1 by S is 1. Inverse Laplace transform of a 1 by 1 S plus 1 by T is e power minus T by tau. Tau is T. So this is the response of a step response of a first order system. See, 1 minus e power minus T by tau. Now substitute T value equal to T or tau, capital T or tau. Then you will get a C of T is equal to 0.632, where T is known as the time constant and it is defined as the time required for the signal to attain 63.2% of a final or steady state value. So this is the definition for the time constant. The time constant indicates how fast the system reaches the final value. The smaller the time constant, the faster the system response. If the time constant is smaller, then the system response is fast. So time constant is defined as to reach the final to reach the output signal to 63.2% of its final or steady state value. So this is called as time response. Now you substitute different values of T. T is equal to 0. If you substitute, you will get 0. T is equal to 1. T you substitute, you will get 63 point or 0.632. If you substitute a T is equal to 2T, then you will find 0.865. As per the if you observe, the output response is exponentially increasing order as time progresses. As T value is increasing, the output or C of T is also increasing. At T is equal to 0, it is 0. At T is equal to infinity is 1 maximum. So the T value is increasing from 0 to infinity. The output of a step response or step output of a first order system is also increasing order. Let's sketch the output waveform. So this is our input, that is step signal or a DC signal. So I am applying this DC signal to a first order system. So this is my first order system. So this is the output response. As at t is equal to 0, it is 0. As t increasing, the response of a system is also increasing. Okay. So this is the minimum time required. This is the minimum time required. Array, it is a time constant. Time constant is defined as the response of a system to reach the 63.2% of its final value. So this is the time constant. Okay. So this is a step response of a first order system. Now let us take one example. For one different example. First order response of a system is C of S by R of S is equal to K by 1 plus tau S. So what is K? K is the DC gain of a system, and T is the time constant of a system. Time constant is a measure of how quickly the first order system respond to a step input. For a step input, how system is quickly response is called as time constant. And DC gain of a system is the ratio between input signal and the steady state of its output. So see, for example, I am taking a forward path gain G of S is equal to 10 by 3S plus 1. Okay, I am taking 3 as a common. So 10 by, what will happen? 10 by 3 into S plus 1 by 3. 10 by 3 by S plus 1 by 3. Okay. So here 10 is, what is 10? 10 is the DC gain of a system. What is 3? 3 is the time constant of a system. Okay. For this system, you see, this is the DC gain value and time constant we have to find now. So for that, what we have to do, we have to make the system like this, S into 1 plus some tau S. This form we have to make. So given G of S is 3 by S plus 5. So I am taking 5 as common. I am taking 5 is common. Okay, see. If I take 5 is common, 3 by 5 will be in numerator and 1 plus 1 by 5 into S. So this is a DC gain. This is a time constant. DC gain is 3 by 5 and time constant is 1 by 5. Thank you.